In this video, I'm going to demonstrate how to calculate a confidence interval using a sample. So a confidence interval is going to tell us either a 95%, 99%, or 99.9% confidence interval, a range of values in which we think that the population parameter will actually fall. So here we have a sample. Our class of 55 people has a mean age of 19.8. So our best guess, our point estimate for the population's age would be 19.8. However, we know that there's sampling error and that sometimes our point estimate can be off. So we calculate a confidence interval so that we have a wider range of values with which the actual population parameter can lie. So here we have our formula for finding the confidence interval. It's y bar, which is the mean of our sample, plus or minus z, which is a specific z-score that corresponds to the confidence level that we want, times the standard error of the mean. So this, written out in a different way, is these two equations here. So we have y bar, which is the mean, plus z times the standard deviation divided by the square root of the total, which is n. So the standard deviation divided by the square root of the total is the standard error of the mean. These two things are equal. Now, we divided the confidence interval up into two equations because this plus or minus actually means y bar plus z times standard error of the mean and y bar minus z times standard error of the mean. So that's what's represented here. Now for the z, it's only ever going to be one of these three values, okay? It depends on which level of confidence we want in our confidence interval. If we want a 95% confidence interval, we would use a z of 1.96. If we wanted a 99% confidence interval, we would use a z of 2.58. And if we wanted a 99% confidence interval, we would use a z of 3.3. Okay? So we just plug one of these three values into that z spot. Y bar is always going to be given. In this case, it's 19.8. So the only thing we actually need to calculate is the standard error of the mean, which is the standard deviation divided by the square root of n. Okay? So here we're going to do standard error of the mean equals the standard deviation, 1.4, divided by the square root of our class size, which is 55. Okay? So now, we're just going to do that math. The square root of 55 is 7.42. Okay? So now we're going to take 1.4 and divide it by 7.42. And that's going to give us our standard error of the mean. So our standard error of the mean is 0.19. Alright? That's rounding to 2 decimal places. So this is the value that we are going to plug in here. Okay? So to find a 95% confidence interval, we would do y bar, which is 19.8, plus z for 95% confidence interval is 1.96, and we would multiply that by 0.19. Okay? And we would do the same, 19.8 minus 1.96 times 0.19. Okay, that will give us our lower and our upper bound for our confidence interval. So let's do 0.19 times 1.96 because we have to remember our order of operations. We do multiplication before we do subtraction and addition. So that's going to be 19.8 plus 0.37 and 19.8 minus 0.37. Alright. So our upper bound is going to be 20.17, and our lower bound is going to be 19.43. So our 95% confidence interval for this data, our best guess of where the population parameter lies is somewhere between 19.43 and 20.17. Now, in order for this to be an accurate confidence interval, we have to make sure that our sample is a random sample, right? In this case, our sample isn't a random sample, so we can't be sure that this confidence interval is correct. However, if we did have a random sample, then this would be our best guess at what the population parameter would be, okay? So, to do a 99% confidence interval, we're going to do the exact same equation, except instead of 1.96 for z, we're going to do 2.58 for z. So it'll be 19.8 plus 2.58 times 0.19 and 19.8 minus 2.58 times 0.19. Okay? So the only difference, the only thing you change when you're going from a 95% to a 99% or a 99.9% confidence interval is this z-score. Okay? So you're just multiplying the standard error of the mean by a different value. So 2.58 times 0.19 is 0.4902, or just 0.49. So 19.8 plus 0.49 and 19.8 minus 0.49. So the upper bound is going to be 20.29, and the lower bound is going to be 19.31. So our confidence interval is 19.31 to 20.29. Now you notice that this confidence interval, the 99% confidence interval, is a little bit wider than the 95% confidence interval, because we have to be more sure that these values contain the actual population parameter. We have to widen the range. That's why as you increase your confidence interval level, your range is also going to widen. So that's confidence intervals. You just do this mean plus z times the standard error of the mean, and mean minus z times standard error of the mean. And that's it. You have your lower and your upper bound. I hope this helps.